The last discrete probability distribution that we're going to talk about in Chapter 4 is called the Poisson distribution. Okay? And this is one where the random variable satisfies the following conditions. The experiment consists of counting the number of times an event occurs in a given interval. And that interval can be something like time, or area, or volume. Number 2, the probability of the event occurring is the same for each interval. And number 3, the probability of occurrences in one interval is independent of another interval. The formula for the Poisson distribution is the probability for that random variable can be found by doing e to the negative mu power times mu to the x power divided by x factorial. Now, a couple of things. Mu, remember, is the mean, and that is a good clue for when you're going to use this type of distribution, because a lot of times the problem will mention, this occurrence has a mean of this. So that's a good clue to look for when you're deciding if you want to use this distribution. Another thing, too, is this e value. Now, if you remember back to Algebra 2, e is actually a representation of a number like pi. E has approximately a value of about 2.718281828, and so on. And it's a repeating decimal that's non-terminating. Okay? However, this value is programmed into the calculator, and it's on the scientific calculators as well, but just to show you the graphing, over here on the left you have this natural log key, the ln button. The e function is right above that, so you would just hit second and then the ln key, and it will give you that value. So you don't have to type it in each time. So let's look at the first example on the next page. It says the mean number, and again, there's that word mean, which kind of gives you the clue that you're wanting to use this distribution method. Okay? It says the mean number of accidents per week at 152 in Blue Jay Drive is 4. Okay? What is the probability that the next week there will be 5 accidents at this intersection? Okay? Well, for the formula, you need the values of mu, or your mean, which is 4, and we are specifically looking at the random variable x as 5. And so we have everything we need to run this probability. So the probability that there will be 5 accidents, we're going to do e to the negative 4th power times 4 to the 5th power divided by 5 factorial. Now, you can pretty much type this in all at once. If you're going to separate, I would find this value, then this value, then this value. Okay? Or focus on finding the value of the denominator and then just dividing by 5 factorial. And you should get an answer of about 0.156, or approximately 15.6% chance that there would be 5 accidents there at this intersection next week. If you look at example B, it says, what is the probability there will be less than 3 accidents next week at this intersection? Well, this is one where you really have to kind of think about it as an or problem. Less than 3 means there could be 2 accidents, 1 accident, or no accidents. And so you really have to run the formula 3 times, get the separate probabilities, and then add those up to get the total probability. And then part C, it says, what is the probability that there will be no accidents at this intersection for the next 3 weeks? Well, again, your mu, or your mean, is still 4, and this we would be focusing specifically on just 0 accidents. And here is how that problem will set up.